obviously, then it's going to be your first exposure. Alcohols can be considered relatives of water. And a Lewis structure for the water molecule looks like that. If we replace one of the hydrogens of the water molecule with an R group, we've got an alcohol. And that R group can be any kind of carbon grouping. Methyl, ethyl, isopropyl would be a benzene ring. They all represent alcohol structures. And so you can see from that, and we'll see that as we encounter it here in these slides, that the properties of alcohols share a lot in common with water in terms of their behavior because of that close relationship. The water molecule shown here, 104.5 degrees bond angle between the hydrogens. This is a space filling model. And now we've got methyl alcohol and methanol shown here. And notice that the bond angle is similar, but not exactly the same. Why would the bond angle be a little greater here for methyl alcohol than we see in water, do you think? Yeah, this methyl group here is sterically interfering with the hydrogen. And so the scissoring is scissored a little further apart. That makes sense.
Okay. Does that change the reactivity a little bit? I was reading this. I mean, does the 108 make it more reactive or anything like that? I don't know.
You know, in terms of the common properties that we look at, there's not much difference.
Okay.
If we look at the acid-base behavior, almost identical. So it isn't a big difference. It's just a matter really of repulsion, steric repulsion. Oops. And this is what we just went through here. Alcohols can be classified as primary alcohols, secondary alcohols, or tertiary alcohols, depending on the nature of the carbon group to which they're attached. Primary alcohols will be alcohols where the carbon has only one carbon neighbor. And so like ethanol, methanol would be primary alcohols. Secondary alcohols are those where the alcohol, the hydroxyl group, is attached to a carbon in the middle of the chain. Okay, where it's got two carbon neighbors, and then a tertiary alcohol will be one where the alcohol is attached to a tertiary carbon. So, and you know what these terms mean, right? Okay. And finally, aromatic alcohols, which are called phenols, have the alcohol be directly attached to a benzene ring. And it can be just plain benzene, or there can be other things attached, bromobenzene or nitrobenzene. They affect the alcohol behavior themselves. The other groups that are on the ring actually affect the ring's behavior and affect the alcohol's behavior as well. Examples of what we were just talking about here. Our alcohol group is on a primary carbon, so this is a primary alcohol. Secondary alcohol, where our alcohol group is on carbon number 2 of a butane. And here, the alcohol group is on a doubly branched carbon. And that would be called tert-butyl alcohol. What would the IUPAC name for that be? We haven't seen that yet, but anybody that remembers nomenclature?
Be two, or it'd be a two something else.
And there are 4 carbons, and that's why it's called tert-butyl alcohol. But it's actually, if I look at any, no matter how it's laid out, there's 3 carbons. It's going to be a propyl. So 2-methyl, 2-propyl. Can you see that? This is pretty commonly called terpene alcohol. The IUPAC name would be 2-methyl 2-propyl. Let's get into IUPAC nomenclature. We take the longest carbon chain that contains the alcohol group, the hydroxyl group, and that becomes the parent chain. We drop the E ending from the alkane and add an OL suffix. So butane becomes butanol, propane becomes propanol, and so forth. We number the chain from whichever end is closest to the alcohol group and give the alcohol a number. So I could have 2-butanol, for example, or 3-heptanol. Does that make sense? All of the other substituents then are numbered accordingly. The alcohol group now is setting the numbering pattern. Okay, the number from whichever end is closest to the alcohol group. So here's some examples. I've got this guy right here. This is going to be the longest continuous chain, or I can think of it like that. That is going to be a 1-propanol with a methyl group on carbon number 2. So it'll be 2-methyl, 1-propanol. What you're going to find, and you've already been exposed to this in 235 a little bit, is that we have a priority system at work in our impact nomenclature. Different functional groups, like alcohols, have a priority in terms of numbering the chain. The alcohol group is more important than anything that we have thus far. It's more important than bonds, triple bonds, halogens, anything else. Okay, and so no matter what else is present on the structure, you're going to number from whichever end is closest to the alcohol. All right? That's what's going on here. Now, here, this is just going to be 2-butanol for obvious reasons. By the way, the new nomenclature that's being pushed by IUPAC is being shown here in blue. Did you discuss this in your other class? What's going to happen for a while is you're going to need to be bilingual because this is the nomenclature method that IUPAC is pushing for the future, but there are a lot of chemists out there working with the old system, and so you're going to need to be comfortable with both. So you're going to need to recognize this is both 2-butanol or butane 2-ol. Can you see what I'm talking about? And so it's inconvenient, but every once in a while IUPAC makes a revision in how they suggest nomenclature ought to be done, and we're in that process right now. Right here, this is what we were talking about a moment ago. This is a propane with an alcohol group on carbon number 2 and a methyl group on carbon number 2. So this will be 2-methyl 2-propanol or 2-methyl propane 2-ol with the new system. All right. We can have alcohols and double bonds present. Alcohol is higher priority than the double bond. So even though I've got a double bond connecting carbons 1 and 2 on that end, the alcohol group has priority in terms of numbering the chain. So I'm going to number from this end because it's closer to the alcohol. And so this is going to be a 2-pentenol. And then what I do is I split the name. So 4-pentene, the 4 tells me where the ene is, the 2 tells me where the ol is. Does that make sense? The highest priority group is always the last modifier in the name. Are you following that? The new nomenclature, which this starts to get awkwarder and awkwarder, is pent 2-ene 4-ol. Excuse me, 4-ene 2-ol. And for those of us who are a little older and grounded in a different nomenclature system, we really struggle with that. A lot of people are not going to adapt to this. That's why we're going to be flexible enough to deal with the old timers that don't do it and the new timers that are going to adapt to it. All right? Does this make sense? Are you following along with this okay? Now, here's the priority we were talking about. Halides, Ethers and alkanes are right at the bottom in terms of their priority. Alkynes, alkenes are higher priority than anything. So methyl groups, ethyl groups, and chloro groups, and bromo groups right at the bottom. Double and triple bonds are higher priority than any other substituents that you might have there. Then amines, then alcohols, and that's where we are now. This priority list, I believe, is in the inside cover of your textbook. Okay, so if you need this list for reference purposes. Notice that we're not done with this priority. Later on, as we cover other kinds of groups, they're going to deprioritize the alcohols. So the alcohols will be bumped back by ketones and aldehydes and carboxylic acids. All right? Now, in this particular case, as we just talked about, the carboxylic acid, this guy right here, is the #1 priority. It is the highest priority group under all circumstances in nomenclature. And so that the carboxyl group, based on its structure, and you may not have seen this, but this carbon is double bonded to one oxygen and single bonded to the OH group. That structure will, in order to exist, has to be overlaid. And so that will be carbon #1 under all circumstances. And everything else will be given a number. If my alcohol has been deprioritized, I call it a hydroxy group and give it a number. So this is 4-hydroxybutanoic acid. In older nomenclature, when I've got a high priority group like a ketone, an aldehyde, a carboxylic acid like this, in older nomenclature, rather than numbering, they were given Greek letters. Next door was alpha. One door down was beta, and then one door down was gamma. So this would also be called gamma hydroxybutyric acid. That's where that comes from. This is a beta. I don't know if you know that. This is GAB. Okay, and it's got 2 functional groups on it. But the alcohol in both cases has been deprioritized. This method is still fairly commonly used. Instead of butanoic acid, which is what I would recommend this be called, an older name is butyric acid. You've still got the BUT root in there indicating what? 4 carbons. So this would be gamma hydroxybutyric acid, but the new method would be 4-hydroxybutanoic acid. Okay? We haven't covered acids yet, so we're still all sorts of things. There are also a lot of common names. This is isobutyl alcohol. What does the iso mean?
1 in. 1 carbon.
It means a methyl branch, 1 carbon in from, if we're in biology, we call it the distal end. Okay, you understand what I'm saying? And I could have isobutyl chloride, I could have isobutyl alcohol, I could have isobutyl anything. But this part is the isobutyl group. Notice that I've got a methyl branch, 1 carbon in. And isopropyl, isobutyl, isobutyl, all fit that pattern. That's what iso means. In this particular case, this is called sec-butyl alcohol.